Good morning, student. Welcome to my class. Last class we discussed what is resolution of vector and how a vector split into its rectangular component. So why we call rectangular component means the angle between two vector A and vector B is always 90 degree. I am just repeat my sentence here, that is suppose vector A and there is two dimensional case. This is origin x axis and here this axis y axis, clear, and this vector make an angle theta with x axis. So what is the component, rectangular component of the vector A along x axis and y axis? So at first we have to draw a perpendicular here and this angle 90, and this angle is known this side or this distance you can say is known as component of vector A along x axis. So here you can say projection also. Projection of vector A along this x axis, here we can write that is A cos theta and this component A sin theta. बुझेला ना, जो साइड एंगल लगी थी हम कौन डबा A cos theta and this side is also known as A sin theta, and these are known as rectangular component of vector A along x axis and y axis, clear. So now let's start here. Today's important chapter, today's important concept we have to discuss here, that is known as multiplication of vector. Multiplication of two vector or multiplication of vector, clear. We already discussed that is suppose there is a physical quantity 5 liter plus 2 meter, then what will be your answer? 5 liter plus 2 meter, because in this case, in addition case, we have to use principle of homogeneity, and that liter and meter are two different physical quantity, and according to principle of homogeneity we cannot add two physical quantity when their nature are different. अलगा अलगा नेचर थिला हमें केबे ऐड करि परिबा नाही किबा सबट्रैक्ट करि परिबा नाही. सो दिस इज नॉट वैलिड इन दिस केस, क्लियर. और सिमिलरली सपोज 5 liter minus 2 meter and this is not significance, but in this case we can add 5 liter plus 2 liter which is equal to 7 liter, means same nature of physical quantity can be added or same nature of physical quantity can be subtracted in addition case, clear. So suppose I am writing here R equal to A vector plus B vector. This is the resultant vector. So what is A and B? A and B are two vector which possess equal nature. Equal nature means you can say suppose 5 Newton 5 Newton towards east I am writing here plus 7 Newton towards west, like this. Here nature are equal, 5 Newton and 5 Newton also here, clear. So I cannot write that is 5 Newton plus 2 meter per second, which is meaningless. But in case of multiplication of two vector, while you are multiplying, then multiplication of two vector means I am writing here force. So what is force? The symbolical representation of force, that is F equal to mass into acceleration. And what is the direction of force? It is always direction of acceleration, means this direction, clear. And here what is mass? Mass is here scalar quantity and its unit, that is kg. And here what is A? A is acceleration and its unit meter per second square. But we get a new physical quantity, but these are two different physical quantity and different nature. But here in addition case, two different physical quantity which possess opposite nature, which possess different nature, we cannot add or cannot subtract. But when two physical quantity are opposite or different in nature, means here kg and here meter per second square, these are two different nature. But in case of vector we can multiply this, clear. आम वेक्टर केस रे सेम फिजिकल क्वांटिटी को ऐड करि परिबा, सेम फिजिकल क्वांटिटी माइनस करि परिबा, बुझिला ने बट या को अपोजिट और डिफरेंट फिजिकल क्वांटिटी आम ऐड कर परिबा नहीं कि सब्ट्रैक्ट कर परिबा नहीं बट वी कैन मल्टीप्लाई देम by using vector rule. Clear? And mathematically you can write m equal to f vector divided by a vector, which is meaningless. Why? Because in vector algebra division of two vector which is not possible, then this vector then this form of mathematical can be write here magnitude of a vector divided by magnitude of a vector, like this. Clear? Suppose I am writing one example here, momentum. What is linear momentum? The product of mass into velocity, and here mass into velocity. And what is the direction of momentum here? The direction of velocity is along the direction of, and the direction of velocity is also the direction of momentum. But here there is two different physical quantity and their nature different, because mass is here kg and what is velocity? Meter per second. Clear? So in vector algebra we can multiply two different physical quantity, their nature different, kg, meter per second, but we cannot add them. Clear? So now we will discuss here multiplication of vector. Clear? We already discussed multiplication of vector with a scalar, and at that time we get a new vector. Means we already discussed, I am writing here just scalar into one vector. So scalar means I am writing here that is mass into that is velocity. So we get a new physical quantity, that is momentum. Clear? And here mass velocity equal to p. So the direction of velocity is the direction of momentum. This. Clear? Okay. And we already discussed scalar means you can take any number, that is k into velocity. K means that is real number. K may be +1, that is -1. Then at that time the velocity may be changed here. Clear? And it give another one vector. Suppose here k equal to +1. So at that time here 1v which is equal to r, means the direction of v is along the direction of r. Clear? Or the direction of r is along the direction of v is here. And if I write that is k equal to -1, so at that time v equal to r vector, means the direction of r a resultant vector which is opposite to velocity vector. Clear? So this case we already discussed. Now we will start product or multiplication of two vector. So you have to remember this concept, means here we have to multiply vector into vector. Clear? And here there is two type of vector into vector product, and first one you can say that is scalar product, or it is known as that is a dot product of two vectors. And second one that is cross product, or you can say vector product, that is cross product of two vectors. So first we will discuss here two vector, and that is scalar product of two vector, and next we will discuss vector product, means cross product of two vector. Clear? So now let's start scalar product of two vector or dot product of two vector. Dot product of two vector. So in this case, what is dot product of two vector? Means we have to write the representation of dot product of two vector. Suppose there is two vector and one vector this direction, suppose a vector, and another one vector is here and suppose this is B vector, and angle between A vector and B vector is suppose theta. Clear? And the representation of dot product we can write here, that is A vector dot A vector into B vector, and we have to use here a symbol that is a dot. So that's why it is known as dot product of two vector, and which give a another one physical quantity, and this physical quantity we will find here, and that physical quantity is scalar. Scalar physical quantity. Scalar physical quantity. So how can we derive a dot product of two vector? Means first we have to draw here a perpendicular, and this angle is here 90 degree, and we already discussed how to resolve a vector into two rectangular component. Here this vector is B vector, and its rectangular component along this axis, or suppose A vector, and we already know this is B, and its rectangular component this side we can write B cos theta, and this direction, and its component along this direction, that is B sin theta. Clear? And A dot B is a scalar quantity, so in this case we have to write here, suppose I am taking one example, that is work. And what is work? Work equal to force into displacement. Force into general multiplication, suppose force into displacement. And what is work? Work is here scalar quantity. Scalar physical quantity. So how we get scalar physical quantity, that is work done? Means force, and which type of force and displacement? In this case we have to apply a force along the direction of displacement, or along displacement. Force displacement direction रहबा दरकार. Means suppose I am taking here the body displace this direction and apply force this direction at angle theta f. Then at that time we have to draw two rectangular component, and this component is known as f cos theta, and this component f sin theta, and body displacement from position A to position B. Suppose this is displacement S. So in this case we have to write displacement, and which force we have to take here, because there is two force, one F cos theta and another one F sin theta. So in this case we have to take force. This force means the force which is along the direction of displacement, means same line of action. So here F cos theta and S is your work done. So in this case work done can we write F cos theta into S. So similarly in this case the vector of B which resolve into two rectangular component, one is B cos theta and second one B sin theta, but here we have to take only this component. This component means B cos theta, and I am writing here B cos theta into this magnitude, means this magnitude along A vector, so you can write simply A. Clear? And that is A B cos theta, or you can write that is A into B cos theta. Means what is B cos theta? Projection, or you can write rectangular component, or component of vector B along vector A. Component of vector B along A, or simply you can write A projection. It is also known as projection. Projection of B vector on A vector. Projection of B vector on A vector means this is projection. This is projection. Clear? जब तुम एपा गुटा लाइट पकेइबो एबे ए गुटा वेक्टर अछि ना नहीं, ए छाई ए साइड आसी कोठी पड़िया दरकार ना, ए यार छाई सब आसी कि ए वेक्टर ऊपर पड़ियो. दैट इज नोन एज प्रोजेक्शन ऑफ वेक्टर, और सिंपली यू कैन से प्रोजेक्शन ऑफ वेक्टर बी. बी वेक्टर रो छाई कोठी पड़िला ना ए वेक्टर ऊपर आ केते डिस्टेंस रे b cos थीटा. सो हियर ए projection A into projection of B on A. B ro projection A vector upore, or simply you can say A into component of vector of B along A direction re B ro component ta kete achi. Clear? And you can write here the AB cos theta, or you can write simply A means magnitude of A vector. We already know why, because magnitude of A equal to A. So here B means magnitude of B vector into cos theta. And what is theta? Theta is here angle between A vector and B vector. Clear? And so you can write here A dot B vector means A multiplication or A product of B, but here we have to use dot. A dot B equal to AB cos theta, and this is, you can say, C. I am writing here C, and C is your scalar quantity. Why? Because this is magnitude and B also magnitude, and cos theta also trigonometric function. Clear? And this total term will give a only magnitude or numerical value here. Clear? So that's why we get here a scalar quantity. Scalar quantity. So you have to remember the dot product of two vector which give a physical quantity, and that physical quantity is your scalar quantity. Clear? So remember one point is here, that is A dot B vector which give a resultant vector, and the resultant vector suppose C, and C is here scalar physical quantity. Clear? So the dot product of two vector, the dot product of two vector will gives a scalar physical quantity. Clear? We can take one example. I am just writing before here, that is work done. And what is work done? Work done equal to force into displacement. Force into displacement. But we already know force and displacement are two vector quantity. But what is work? Energy, which don't require any direction. That means this is only magnitude. So this is scalar quantity, means force we have to multiply here into displacement also vector. So we have to use here dot product here. Force dot product of displacement vector, we get a scalar physical quantity, and that scalar physical quantity is work done is here, that is scalar. Clear? Similarly, we already know that is power. What is power? Power equal to work by, or you can say work by time, or work, what is work here? Force into displacement by time, or simply you can write F vector dot here S by T, displacement upon time you can write velocity and velocity. Clear? So F vector dot V vector which give a scalar quantity, and that scalar quantity is known as power. So what is power? Power is here the resultant product, and this is a scalar physical quantity. Clear? Okay. If I want to write other format, suppose this is vector A, and there is another one vector, suppose this vector is B vector, and which make an angle, this angle is theta. Now draw a perpendicular from point A on the vector of B, and this is perpendicular. Clear? Now resolve vector A into two rectangular component, so its component along this direction. So its component along B can be write means this vector, or this is the projection of vector A. Projection of vector A along B, that is A cos theta. जो side angle लगी थी वो हमें तो कौन ना cos theta. Now draw a rectangle here like this, and if this is a cos theta, then its perpendicular component will be this direction, and it will be A sin theta. These are rectangular component of vector A. But A cos theta is along the direction of B. But we have to choose here in dot product of two vector, the component of vector A along the vector means same line of action at that time. So you can take here, that is A vector dot B vector equal to, means magnitude of B, this is magnitude of B into component of vector A along B or projection of vector A along B, and here A cos theta, and you can write here that is B into component of A vector along B vector, or you can write B which is equal to, that is projection of A vector on B vector, clear? And this is simply, you have to remember, A dot B vector equal to A B cos theta, where theta is angle between A vector and B vector, clear? This is all about dot product of two vector. Now we have to discuss properties of dot product of two vector. So now let's start first properties. Properties of dot product, clear? So first property, it obey commutative law. So what is commutative law? Means A dot B which equal to B dot A. How? So suppose this is LHS, left hand side, A dot B means there is one vector A and another one vector is here B, and A dot B means A vector and this make an angle theta. Suppose this direction I am taking here. So A dot B equal to, you can write magnitude of A means A, magnitude of A vector and magnitude of B vector, and cos or cosine of angle between A and B, and here cosine of angle between A and B is here theta, clear? Or simply you can write A B cos theta. Okay, come to right hand side, B dot A, that is magnitude of B, magnitude of A into cosine B dot A means this vector A and another one vector B, but we have to choose angle, suppose this direction B dot A, and this angle now you can take here, suppose minus theta, clear? So in this case we can write magnitude of B means B vector, simply you can write B magnitude of A into cos, here minus theta, and you will study in mathematics cos theta is even function. So what is even function? So cos minus theta you can write, that is cos theta, so it is known as even function, and there is another one odd function, so that is sin minus theta equal to minus sin theta. এই দুটা टर्म बर्तमान तो मन रखा पड़ो, cos minus theta equal to cos theta equals a even function, तो mathematics रे पड़ो, and then sin minus theta equal to minus sin theta, it is known as odd function. So I am writing your minus cos theta, so cos minus theta equal to cos theta, so you can write here that is BA cos theta, or which equal to BA AB, same thing, so you can write AB cos theta. So here this is product case and this is product scalar quantity, so A dot B equal to B dot A, proved, clear? So dot product of two vector obey the commutative law. Next properties, it also obey distributive law, law of distribution means, suppose I am writing here one vector A dot B plus C vector, and which will be equal to A dot B. So A dot B vector plus A dot C, because multiplication case A dot B and A dot C, but here dot sign you have to use, that is A dot C vector. Clear? So this is distribution law. And next properties, suppose properties number 3, dot product of two equal vector, dot product of two equal vector is square itself. Is square itself means, suppose I am writing a dot product of two equal vector, one vector A and another one vector A. Dot product of two equal vector which is equal to, you can write the magnitude of A vector into cos theta. What is theta? Or theta is angle between two vector A and B, but here if this is the direction of A, equal vector means both magnitude and direction of these two vector should be equal. So vector A is here and another one vector also same, vector B, or you can say this is also A vector, same direction and same magnitude. So here theta is angle between two vector is 0 degree, you can put here 0, and you already know the value of cos 0 which is equal to 1. Then A magnitude of A, simply you can write A, magnitude of B you can write A, then the answer A square. So the dot product of two equal vector is square itself. Clear? So you get dot product of two vector is square itself. This is third property. And property number 4 you can write the dot product of two, the dot product of two perpendicular vector is always 0, means two vector and these two vector are perpendicular to each other. Suppose one vector here A vector and another one vector B which is perpendicular to vector A, and here angle between them is 90 degree. So in this case if you multiply or dot product of two vector, vector A and B, A vector dot B vector equal to magnitude of A vector, magnitude of B vector into cosine of angle between them, and here angle between them is 90 degree. So you can write 90 and the value of cos 90 which is equal to 0. So we get here that is 0 and A dot B vector equal to 0, not 0 vector. Why? Because we get the product of two vector quantity, and if we multiply a dot here then we get a scalar quantity. So dot product of two vector is a scalar and which is equal to 0. But conversely from this relation, conversely you can say it is does not imply that, it does not implies that A dot B vector equal to 0. Why? Because it may, if A vector equal to 0 vector or B vector equal to 0 vector, जदि A वेक्टर मैग्नीट्यूड 0 वेक्टर आ B वेक्टर मैग्नीट्यूड 0 वेक्टर हला ताले ए दिरा वेक्टर परपेंडिकुलर केते हबो जेतो तार मैग्नीट्यूड थिबो आ डायरेक्शन थिबो पर्टिकुलरली, बट एठी कोन ना A वेक्टर 0, व्हाट इज 0 मींस नल वेक्टर एंड नल वेक्टर मैग्नीट्यूड कोन 0 and direction arbitrary direction undefined bhai ame define kari paribani. Clear? So in this case which is conversely ये तो satisfy helani. So at that time this case we have to write na a vector does not equal to 0 vector and another one vector b which does not equal to 0 vector. Clear? At that time this condition is also proved. Clear? So these are the properties of dot product of two vector. And you can take another one example or another one property you can say. Suppose property b, if two vectors are acting opposite to each other, if two vectors are opposite to each other, then suppose one vector is here, vector a, and another one vector is here, that is b vector, and angle between a vector and b vector here 180 degree. So find a vector dot b vector. So a vector dot b vector equal to ab cos theta, and theta is here 180 degree, and the value of cos theta and cos 180 is -1, so we get minus ab, that is a dot b. So this is minimum value we get in dot product. So when angle between two vector is 180 degree, at that time we get the resultant vector which is minimum value. So what is the condition for maximum value? And condition for maximum value is that when two vectors are acting equal direction or parallel to each other, when angle between them is 0 degree, at that time we get a maximum value. This is not minimum. Here negative sign is minimum value and this is maximum value. Clear? So these are some properties of dot product of two vector. Clear? Okay. So you have to remember all the properties of dot product of two vector. So next properties, suppose if we multiply a scalar with dot product, suppose m is here scalar and a vector dot b vector is here, and the resultant or result will be that is m a dot b, means you can write here that is a vector dot b vector, or you can write m into ab cos theta. Clear? And next properties which is important properties, and the properties is known as dot product of orthogonal unit vector. So what is orthogonal unit vector? And we already know there is 3 axis x, y and z axis. Along x axis and it is represented direction means unit vector I cap, y axis j cap, and along z axis that is k cap. Now we have to first find I cap dot j cap, dot product of orthogonal unit vector. Why it is called orthogonal? Because the angle between ij is 90, jk is 90 and ki is also 90 degree. Clear? So I dot j equal to I magnitude into j magnitude into cos theta. What is theta? Theta is angle between I and j, and I and j is here 90, so cos 90 equal to 0, and we get 0 means I dot j equal to 0. So similarly you can say j dot k vector equal to magnitude of j, magnitude of k cap, and here cos 90. Why? Because angle between j and k is here also 90 degree. 3 vectors are or 3 axes are mutually perpendicular to each other, and angle between x and y 90, yz 90 and zx also 90. So here cos 90 equal to 0, and we get here 0 means j dot k vector which equal to 0. Similarly, you can write k dot I which equal to k vector dot I vector magnitude into here also cos 90. Why? This angle is also here 90 degree and cos 90 equal to 0. So we get k cap dot I cap equal to 0. Clear? So now we get here that is I dot j equal to j dot k equal to k dot I which is equal to 0, not 0 vector, only 0. So you have to remember this condition. Now I am writing another one example. Suppose I cap dot I cap, and what is its value? Magnitude of I cap and magnitude of I cap into cos I same direction, means x axis is here I cap and theta is here 0 degree. So here you have to write 0 degree and cos 0 equal to 1. Then magnitude of unity vector, we discussed that the magnitude of unity vector always 1, but it gives the direction when we multiply a unity vector with a scalar quantity. Clear? So its magnitude is always 1. यूनिट वेक्टर मैग्नीट्यूड सब बेले 1 आ जो यूनिट वेक्टर आम गोटे स्केलर संगे मल्टीप्लाई करदे से कौन देदेव गोटे वेक्टर क्वांटिटी दे पारिबो. क्लियर? सो इट्स मैग्नीट्यूड इज ऑलवेज 1 एंड 1 into cos 1 and we get 1. That means I cap dot I cap equal to 1. Similarly j cap dot j cap equal to 1 and k cap dot k cap also 1, or simply you can write I dot I equal to j dot j equal to k dot k which equal to 1. Clear? So here I j k I equal to 0, but I j k equal to 1. So these are the dot product of orthogonal unit vector. Clear? Okay. So now let's start. Dot product of two vector in rectangular component form. Dot product of two rectangular component or rectangular component vector. Clear? Okay. So now let's start. Suppose in 3 dimension I am writing 3 dimension case, and there is a vector, suppose a vector, and here x axis, this is y, and here z axis. So what is vector a? How can we write here? That is a vector equal to ax I cap plus ay j cap plus az, that is k cap. We already know this relation. Clear? Ax I cap, ay j cap, and az k cap. Now we have to solve this relation. So another one quantity you can say. Similarly b vector can be write bx I cap, by j cap, and bz k cap. Clear? Now we have to find here dot product of these two vector, vector a dot vector b. Then how can we multiply these two vector? A vector dot b vector. So its value is here ax I cap plus ay j cap plus az k cap dot b vector is here, that is bx I cap plus by j cap plus bz k cap. Now multiply. So first we have to multiply ax I cap with this total term, and again ay j cap with this total term, and az k cap with this total term. So if you multiply this term, then we will get ax I cap dot bx, but here bx and ax scalar quantity. And what is vector here? I cap, and I cap is here vector quantity. So here I am writing ax bx scalar. So simply we can write ax bx into I dot, here dot mark, I dot I. So you can write I dot I cap. Again there is positive sign, so you have to place here a positive. Then ax by, so ax by scalar, but I cap and j cap, which is vector, so we can write here I cap dot here j cap. Similarly ax bz here I cap dot, that is k cap. Again plus, now come to this point, ay bx, so that is ay bx j cap dot I cap. So j cap dot I cap plus ay by here j cap dot j cap, and again plus is here ay bz, so ay bz j cap dot k cap. Again last one term az k cap into bx I cap, so plus, because it is a positive sign, az bx k cap dot I cap, k cap dot I cap plus az by k cap j cap, k cap dot j cap plus az bz k cap dot k cap, so k cap dot k cap. But here we use, that is I dot j equal to j dot k equal to k dot I, which is equal to 0, but I dot I j dot j k dot k equal to 1. So here look at this term here, I dot I we get here 1, I dot j is 0 and here 0, I dot k this is also 0, I j dot I dot j dot I, which is follow commutative rule, so this is also 0, but j dot j equal to 1, j dot k equal to 0, and k dot I equal to 0, k dot j equal to 0, but k dot k equal to 1. So in first line only one term here, and second line this term, and third line this term. So total we get here ax bx here 1 plus first line complete, then second line plus ay by, so ay by plus, then second line complete, come to third line, that is az bz, so az bz, rest term are 0. So this is final answer, that is a dot b vector equal to ax bx ay by az bz. Simply ax bx plus ay by plus az bz, when k cap j cap I cap. So this is final answer. Clear? So dot product of two vector we have to find by using this relation. Clear? So if we take one example here, suppose there is one vector a vector is here given that is 2 I cap plus 3 j cap plus 4 k cap, and another one vector b vector equal to, suppose 3 k cap minus 2 j cap and plus 4 I cap. Now we have to find a dot b, or question here, that is find a dot b vector. So first we have to arrange the term I j k cap, but here I j k in the reverse order. So first we have to write here I cap means here that is 4 I cap. 4 I cap j is here, minus 2 j cap and 3k. So 3k cap is here. Clear? Now we have to multiply a dot b equal to here ax bx with sign. You have to use this relation with sign. Sign sange तुमको रखियार अछि. The plus थिला plus, minus थिला minus. So here you have to look this two term, this relation, and here this is second relation. I cap is here. I cap is here. So 2 4 ja 8. So 2 into 4, because here positive sign, here also positive sign 8. So like then ax bx, here ax bx 4 plus that is ay by, and ay is here 3 into by is here minus 2. But you have to remember the unit vector should be equal. I j cap, here also j cap, then plus az and this is bz, but positive sign. So 4 into 3. Now solve this relation. So 4 to the 8 minus 6 plus 12, that is 20 minus 6, which is equal to 14. This is scalar, which is answer. So a dot b equal to this much. Clear? So in this way you can solve different type of numerical based on dot product of two vector. Clear? So now let's start. How can we find angle between two vector? So here two vector means here a vector, that is a dot b equal to magnitude of a and magnitude of b into cos theta. We have to find here angle between two vectors. So here the general formula, a dot b equal to magnitude a magnitude b into cos theta, and here what is theta? Theta is angle between, this is angle between a vector and b vector. So here we have to find angle. So here cos theta you can write cos theta equal to a vector dot b vector divided by magnitude of a dot b and a vector b vector magnitude and magnitude of b vector, or simply you can write a vector dot b vector divided by magnitude of a is here a and magnitude of b is b. So cos theta equal to a dot b divided by ab, and theta equal to a dot b divided cos theta is cos inverse here. So cos inverse a dot b vector divided by ab. Clear? So by using this relation you can find the angle between two vector. If we take one example here, suppose I am writing a vector a equal to I plus j cap, and b vector is here, suppose that is I minus j cap, and question here that find angle between a vector and b vector, means we have to find here theta. So how can we find this theta? We have to use here a dot b. So a dot b equal to, or you can write directly this formula, cos theta equal to a dot b divided by ab. So here cos theta equal to a dot b divided by magnitude of a vector into magnitude of b vector. So first we have to find a dot b. Clear? So in this question first we have to find a vector dot b vector. So what is a vector? A is I plus j. So here I plus j vector dot b vector means here that is I minus j vector, and we have relation. So look at this case, I cap, here coefficient is 1 and here also coefficient 1 and j cap also coefficient 1 and here also coefficient 1. So simply we can write here the dot product of two vector. If I cap and I cap are equal, then 1 into 1 means ax a dot b equal to, you can write ax bx plus ay by plus az bz. But third quantity here, third quantity is it third quantity k cap, there is no k cap, so third term will be 0. There is no third term, means ax bx and another term ay by. Clear? But we have to use here ax bx and ay by with their sign bhai rakhiya padiba. Then ij, simply you can write here I cap 1 into 1. So ax bx equal to 1 into 1 plus another one quantity j cap, but 1 into minus 1. Here sign minus 1 and you can write 1 into minus 1. Then solve 1 into 1 plus 1 into minus 1. Then answer will be here how much? That is 0. So a dot b is here 0. So we get the value is here 0. Okay, again now a magnitude of a and magnitude of b. Since a vector equal to I plus j and its magnitude we already know. How can we find magnitude? Now under root of ax square plus ay square root over. Here ax is 1 and ax here ax is 1 and ay is 1 also. So a square plus y square equal to 1 square plus 1 square. You have to always use with sign. Clear? So 1 square plus 1 square equal to, we get root 2. Similarly, I am writing here b vector, magnitude of b vector and write rightly. So I cap means 1 square plus minus 1. So minus 1 square on the root. Then we get 1 plus 1 and which is equal to root 2. So we got the value of a, magnitude of a and magnitude of b. Now use this relation to find the angle between two vector. So this formula cos theta equal to a vector dot b vector divided by magnitude of a and magnitude of b. But a dot b is 0 here. So 0 divided by a and b, magnitude of a is root 2. So root 2 into root 2, that is 0 by 2 and 0 by 2 equal to 0 and we get cos theta equal to 0. So cos ro ko value 0, na cos 90 you can say. So cos 90 which is equal to 0 and cos cancel. So theta is here, that is 90 degree. So angle between a and b is here 90 degree. So in this way you can calculate angle between two vector. Clear? So now let's start next properties. Component of a vector. Component of a vector which is parallel to other vector. Component of a vector which is parallel to other vector. Clear? So in this case you have to see carefully. Now two vector. Suppose there is one vector is here and this vector is b vector. Suppose b vector and another one vector is here, that is a vector. And angle between them is theta. Clear? Now we have to find component of vector a. Component of a vector parallel to b vector. How much? We have to find here. Clear? So component of a vector, first we have to make component. Now draw a perpendicular here, this angle 90 and this is the component of a vector. This is the component of a vector along b and another one component here this is perpendicular component you can say, and this is horizontal component along B vector. So component of A vector along B can be write A cos theta. Component of A vector along B, but it is perpendicular component A sin theta, but we need A cos theta. So component of vector A, that is A cos theta. Then which direction? Component of vector A along B. Along B means B रो डायरेक्शन दरकार. डायरेक्शन पे हमको कौन मल्टीप्लाई करिया पड़िबो? जदि हमें क्वांटिटी को वेक्टर करिया पय चाहिबा, सपोज देयर इज ए क्वांटिटी 5 न्यूटन. अरे वेक्टर ना स्केलर, दिस इज स्केलर क्वांटिटी. So if we multiply with a unit vector with this scalar, then this quantity now represent with a vector, means I am writing here I cap. ताले कौन है गला? ये बेटा फोर्स वेक्टर है गला. 5 न्यूटन फोर्स को डायरेक्शन रे ना along x axis. So similarly component of vector A along B means B cap. Why? Because B cap equal to B vector by B vector magnitude. B रो डायरेक्शन माने तुमको बुझी नेबार अछि B cap. Why? Because the direction of unit vector is always the direction of given vector is B. Clear? So component of A vector along B means you have to write here a B cap. Clear? And we already know that is A dot B equal to AB cos theta, and here A cos theta. So A cos theta equal to A dot B vector divided by B. Now use this value here, so we get here that is A cos theta equal to A dot B. So A dot B vector divided by B into, and this is B cap. This is very important formula. A formula को तो मन रखा दरकार. Formula को use करके तुम solve कर पारो numerical. Clear? Or this formula can be write another one format, that is A dot B cap divided by B into, B cap means B vector by B magnitude. So B vector by B magnitude is B. So we get here that is A dot B vector into divided by B, here B square into B vector. So this is the component of vector A parallel to B. Clear? Similarly you can write component of B vector which is parallel to A vector, or simply you can write means parallel to A vector. So you can write A vector dot B vector, or you can write here that is B cos theta into A cap, like A cos theta B cap, similarly B cos theta A cap. Clear? Or you can write here, suppose this is vector vector A, and another one vector is here B. So this vector B and this angle theta, and this component along this direction, that is B cos theta. So component of vector B along A, component of vector B along A. So you can write BA cos theta means that is A dot B divided by magnitude of A. Like here A dot B equal to AB cos theta, but here from this relation you can write B cos theta equal to A dot B divided by A. So A dot B divided by A into here A cap, or we already know A cap equal to A vector divided by magnitude of A, means unit vector. So if we use this value here, then we can write that is A vector dot B vector divided by A into A cap means here A vector divided by magnitude of A. So you can write A vector dot B vector divided by A square into here A vector. This is formula. Clear? So by using this formula you can solve different type of numerical. Suppose I am writing here one question, that is suppose A vector equal to I cap plus J cap and B vector equal to I cap minus J cap, and question is here, find component of vector A. Find component of A vector parallel to B vector. Component of A vector parallel to B vector means you have to use this relation directly. Clear? So here you can write A dot B vector divided by B square into B vector. So first you have to find A dot B, and here A dot B you can write A dot B. If you solve this relation we already discussed, and you will get 0. Clear? And again B square means magnitude of B vector. So here magnitude of B vector equal to, here component 1, here component 1. So 1 square plus minus 1 square under root, which is equal to root 2. So this value will be here how much? That is 0. Clear? So you get A dot B, 1 minus 1 is 0. Okay. So A dot B equal to 0 divided by B square means here root 2 square into B vector, and B vector here how much? B vector is here, that is I cap minus J cap, and finally we get here the value 0 into 0. So you get the final answer is 0, or you can find different type of value. Clear? So this is the find the component of vector A parallel to B, and here 0. There is no parallel component of vector A along vector B. Clear? So these are all about component of a vector which is parallel to other vector. Clear? Next, this is parallel component, and another one component you can write, that is component of a vector, component of a vector perpendicular to B vector, perpendicular to B vector. But here we have to find, we will get parallel component means component of vector A parallel to B. Similarly, component of vector A perpendicular to B means you have to remember this relation, that is A vector minus A dot B vector divided by B square into B vector. Clear? This is formula. You have to remember this formula, and if you use the value then you will get answer. Similarly, component of B vector perpendicular to A vector is here. So B vector minus A vector dot B vector divided by A square into A vector. This is another one formula. Clear? So you have to remember this formula to find component of vector A perpendicular to B and B vector perpendicular to A vector. Clear? So these are all about dot product of two vector, and how to find its properties, and how to find component of vector A which is parallel to B, what is orthogonal unity vector, and what are the dot product of two orthogonal unity vector. Clear? So next class we will start cross product of two vector. Thank you all.